So let's take a look at some things we can do with nuclear chemistry, and the first one is nuclear transmutation. And so nuclear transmutation, we take elements and we make them into other elements. And the way we do this is we basically just shoot nuclei at each other, and when they hit each other, they combine and thus form a new element. So this was done way back when, or originally, by Rutherford, the same guy that did that gold foil experiment. So he was messing around with some nuclear stuff all the time. So he had some nitrogen 14, and he shot some alpha particles at it. He had some uranium that was alpha decaying, right? And he smashed it into some nitrogen. And when he combined the two, he saw that it formed oxygen and hydrogen. So that's pretty cool. What he did was combined nitrogen and neon. Whoops, nitrogen and helium. I don't know what I'm thinking. Helium to make oxygen and hydrogen. And this helium is the alpha particle. So that's kind of a simple example. Nowadays, we have some more complicated equipment. So nowadays, we use particle accelerators to make brand new elements. The caveat here is that these are unstable, and so although we do make them, they last usually for like a fraction of a second. So a picture on the left is some particle accelerator, and then the table on the right is just some examples of some transuranium elements, right? So we basically take uranium, and then we shoot other nuclei at it. Basically, in these things, there's nuclei kind of zipping back and forth at each other. You got to slam them really hard against each other to make new elements. So example of that is uranium plus carbon 12 forms CF244 and 6 neutrons, and so CF is californium. So this was first made at UC Berkeley, which is pretty cool. And so if you look at the periodic table, you can see uranium does, on the 238.03 is its average atomic mass, and then you can see after that, that's all in parentheses, and that's because they don't have an average atomic mass, because as soon as you make them, they start falling apart. So all these elements, you know, it's kind of cool that we've got them, but they're not all that useful in terms of stability. There's still a lot of cool stuff you can learn from creating these things. And you get to name it whatever you want, so that's pretty cool.